Alright, just so you guys know, I just started recording, so don't worry. We'll give you guys a few more minutes to finish up.
Pitching, practice, Sundays and Tuesdays, night workout.
But Olivia was all the way to roughly alone. No, when she was coming out, everyone knew she didn't want to be there. I knew she didn't want to be there because she told me she didn't want to be there. But then she said, "My mom, what happened to go?" And I was like,
I went there. I think I should have. I think
"You don't want to go to homecoming, Mister?" I was either forced to go to homecoming or I would have to go to prom. Exactly. I don't want to do either. They're bad. You gotta be with the people. You gotta be with the people. I didn't have it. I had one thing. No. I had one camp. So that was just it. Because other than that, I was on the dance side.
What?
You dance with the
I have one play and I had Martin doing all this. I went home. I was hungry. Whole day I didn't eat, bro.
Yeah, you're helping me graduate.
Yeah.
Alright, here's the.
Kind of racist.
Hey, talk to Mrs. Zoe. She was the one who wrote cut him. I just made it. Alright, so we've been organized for about 5 minutes now. So, let's go over this. So, I know since we just had our unit on transformations, so I wanted to start off this warm up with some sort of the transformations that you guys are going over. Because what is going on here is going to lead into what we're going to learn about today. So, just gave you guys just a little grid and just boxes to fill out, asking if it was a rigid transformation or a non-rigid. So, what did you guys put down for the first one? Rigid. Rigid. Yes. Why is it rigid? Yeah, you're just moving. You're just sliding it around. All right. Next one, rotation. Rigid or non-rigid? Rigid. Yes. Why is it rigid? Yeah, you're just rotating around a certain point. You're just sliding the image. All right. Compression. What did you guys put for this one? Why did you guys put non-rigid? Yeah. What? Getting smaller. Yeah. So that's you guys changing one of the X or Y coordinates and then just making it get bigger or smaller. So that's changing the shape of the image and it's like angles and it's sidelines. All right. Dilation. What did you guys put for that one? Why did you guys put non-rigid? Good job. All right, reflection. Rigid. So the same reasons why you're sliding down. And last one, stretch. Non-rigid. Yeah. Those are yours? That's all right. You guys missed one. That's all right. But you guys got the point, right? So you guys can tell the difference between what is a rigid transformation and what is a non-rigid one, right? And you guys know the difference between a rigid transformation and a non-rigid transformation, right? All right, perfect. So that kind of brings us into what I'll be talking about today, which is congruency. Do you guys know what congruency is? So what is congruency? Yes, two things are the same. That is pretty much the essence of congruency, is when things are the same. Yeah. So if we have certain shapes and if the shapes all have the same size and all have the same angles, that means they are congruent. I'm going way back when you guys like first started going up. Do you guys remember like when we have a line and you want to find the middle of it, right? That then cuts the line into two equal parts. So we could then say that those two equal parts. Let me use this board over here. We have a line, and then we find the midpoint right here. So now, because we have this is the midpoint, we now have say this segment right here is now equal to this segment right here. So these two lines right here will have the same length, means that they are congruent. So like that is one of the more simple things. Do you guys know what the sign for congruency is? What does it look like? Two squiggly lines with the thing on top? Like that? Right? Yeah. So that is a sign that we could tell. We could use this in math to show that two things are the same. So if we have two triangles are the same, like we could put triangle A, B, and C is congruent to triangle D, E, and F. So we can write things like that. Do you guys know how to tell? I just kind of did it over there. Do you know how to tell if two sides of a triangle are the same? So like if I have a triangle like this, another one like this, and I put this right here. You guys know what that means?
Yep.
Alright, so if I put this angle and this angle, I put it like that.
Those angles are congruent.
Those angles are the same? Alright, what if I do this? Which two are congruent? So this one and this one. So do you guys see why that is? So we could use these dashes to kind of tell which sides are the same and which aren't. So when we start adding more dashes like that, we gotta start looking for the two dashes, and for the angles, I could go like this too. So what's going on in this triangle now?
One is congruent with the top one, and the top one's congruent to the right people, right?
So she had it. They're all different. Because I could use these dashes to then like indicate which ones are congruent. Because then I could go into this triangle over here, and I can map all those ones onto this. So now I can tell that this angle right here is the same as this one. You can see it has three dashes that then lines up with these three dashes. This one dash lines up to this one. Oh, it's the two, you're right. There we go, put it right there. And then my two dashes could add up to that one. So that's kind of how you could use that to show in certain figures what parts are the same and what parts are different. So that's kind of one of the things with congruency that's nice. So, what else did I do? All right, so how can we tell the length of certain like images? If I have like a coordinate, how can I find the length of a certain segment or a certain line? What do we use? This is formula, yeah, right? What's this formula? Anyone write on the board? Oh, who's got? You got? Right on the board. Let's see. Let's see if you got it.
That's so bad.
Last time, that's why I the number.
Perfect. All right, you guys all see this? He missed one part. It's all right. Here, ready? So, what else we use to find distance or the length of a certain side? There's another one.
You can use technically midpoint formula and
Wait, what?
midpoint formula.
Midpoint formula could be one like we did somewhat over there. That's if we want to find the midpoint now, which I mean we could then use that to then if we have the two lengths we then add it together. But there's also another formula. Pythagorean theorem. What's Pythagorean theorem? I love that formula. That's my favorite formula in all math. You guys know like you guys can find out a circle using the Pythagorean theorem. Circle. You can make an entire circle using nothing but triangles. That's why triangles are my favorite. They make up the entire world. Triangle makes a square, triangle makes a circle, and you can find out everything beyond that. Triangles are awesome. When you guys get to more advanced math, you guys will find that. Mrs. Lazard, am I lying? I'm not. Oh, yeah, you can. Oh, we'll get there. Don't worry. You guys aren't there yet. There's like 2 years left. Yeah, no, so Pythagorean theorem is also something we could use because pretty much the Pythagorean theorem is nothing but just this formula, just written a little bit differently. Because pretty much, what is this formula saying to us? This is the change in y squared plus the change in x squared plus the change in y squared equals our distance with the square root. What we have over here is one of the lengths, which is, let's just say, in this triangle, right? These are our 2 points. We could use this as our x, we could use this as our y. So we could literally just say A and B, and this is our C. So we could use the Pythagorean theorem to then find out the distance of formula 2, or of a line, which is also really interesting. So we're going to be using these two formulas right now, and we're going to find some distances, and we're going to try to show if certain things are congruent. So I'm going to go through some examples first, and then when I have the opportunity, I'm gonna give you guys a piece of paper, and you guys are gonna get in groups, and then we're gonna go up on the boards, these lovely boards over here, and then we're gonna go over those examples, and you guys are gonna work in guys in groups together. No, what's so fun about sitting down? You guys can like stand up, like move around, you know, get a little exercise going. It's Monday, I'm sure you guys are a little tired. You guys have homecoming over the weekend?
I don't have the grades.
How's homecoming though? There's a lot of fun
My
times.
mind is still fixed on Friday. That's the
I
problem.
remember my homecoming. I snuck in for 3 at mine.
A name?
You what?
I snuck into homecoming for 3. So, I wasn't like your guy. I'm talking about Alan.
Hey, my bitch, we're twinning!
Alright.
I'm kind of smart right now. I was like, I'm definitely gonna kill this.
Alright, so guys, let's go over the first one real quick.
First one is 2? Of what?
I'm gonna ask a lot of you.
So, first, I'm going to say we have points -1, comma 3. Then I have another point, 4, comma 2. Alright, I want to find the length of this point. What do I gotta do? This formula. Alright, so help me fill it in. What am I putting where and what?
4 plus 1.
4 plus 1. Alright, so we'll do this. Alright, so I have 4 plus 1, which is 5. I have 2 minus 3, which is -1 squared. So what's 5 squared?
26.
What's that 26?
That's what I was wondering.
5 squared? It does equal 26 at the end of it. Plus 1, because 1 times 1. Alright, and then square root of that is square root -26. Alright, so that is just how you use this point. So then we can get another set of points. Alright, next one. What are we doing? Help me fill it in. I need you guys' help. I'm in college, I haven't done this in a while. I don't know these formulas. So it's a -4, comma 6, and it's 1, comma 10 for those of you guys that can't see. What is it? Yep, Adam, so 5. What's this one? Alright, so what's 5 squared? What's 4 squared? What is 25 plus 16? What is it? 41? Are these two congruent?
No.
Why?
Because they have different outcomes.
Different outcomes, yes. For things to be congruent, they have to be the same. They have to be the same side lengths, they have to be the same angles. So when we look at triangles, let's go on to this one. I'm gonna say this angle right here is 36 degrees. I'm gonna say this angle right here is 40. What is this angle?
Isn't it the same or?
Hmm?
You said it.
What's the missing angle?
You said it.
104. Yeah. So how do you get 104? Explain to me how you got 104. Yeah. So he just said it. So he has two known angles, and in a triangle, the angles have to add up to how much? 180. So 40 plus 36 plus 104 equal 100. Okay. All right. Cool. What's my missing angle here? 36. So, are these congruent?
Yes.
Alright, cool. I'm gonna ask this other question right now. Are those congruent? Well, what about the sizes?
No, they're not.
Similar. Oh, I like that. I like that they knew that. Yeah. So, even though all the angles may be the same, dilation, exactly. So that could work. It could get quite tricky sometimes, because if you dilate an image, it preserves all the angles, but it gets bigger. So that means like this segment could be whatever the scale factor is. It could be 2 times greater than this one, but that is something that we have to look out for when we're working with that. So I'm not gonna go pass out. Yeah, I've wasted enough of your guys' time to talk about this right now. So I'm gonna pass out this worksheet. I have over here, I have boards 4, 5, 6, 7, 8, 9, and 10. So I'm gonna split you guys into groups so you guys could use these boards over here. This is fine. Do you have random groups created or no? Oh, she has groups for you guys.
No. I know, do you not wanna use all the boards, cause we could just combine them together. I have them separated into 10.
Miss, you can just leave it at that, miss. You don't have to randomize it.
I'm gonna put
I
see you, I swear to God, I swear.
You guys get, you guys get so worried once you start like randomizing. How much would it be?
Miss, can you redo it, miss?
No.
Let's randomize it, miss. Let's do it again, miss.
Well,
You want your brother?
Miss, can you redo it?
You want your brother? No.
Shut up.
alright, so we're gonna do it how Miss Lazard has it set up right now. So we're gonna do groups of 10. So I'm gonna move this desk over here.
10 groups of 2 or 3.
10 groups of 2 or 3, yeah. So that's what's gonna be going on. Alright, so find your guys' name and let's start walking over to the boards. I'm passing out the papers. No, it's alright, because I'm just giving one to each group. So you're good for here? Yeah. There you are. Alright, so right now we're only working on problem set 1. This Judy's doing the very front of this worksheet right now. It is 5 questions, so it's not too crazy or too hard. Who's over here? Who's at board 7? Right there, perfect. Who's at board 8?
Aiden, nice work.
We got 3 pieces to say.
Who's at board 9?
You can erase anything.
You guys just got one for your 2.
Feels bad.
That's for science.
Yeah.
I didn't notice.
It'll be sad, but that's okay.
There's definitely
They should have taken a picture of it.
there's room around.
I'm sure they did.
Everybody got a worksheet.
Oh yeah, I was waiting for you. Alright, there you go. See ya.
Okay, so we have to do this formula for
Alright guys, remember, you're only doing the first page. You're only doing problem set 1. Work together as a group. That's why you have group members. Which group are you with?
Okay. On your way.
Leave all your guys' work on the board so we can go over it afterwards together as a class. I'm gonna ask a few of you guys' groups to work out these damage.
Yeah. Oh wait. Oh.
We're just supposed to find.
B. Oh, sorry. What is the question for B? And C is what?
C is 32.
And D?
Negative 1.5.
Write it down. Oh, I'm working so hard right now.
At least the markers will
I was
work.
actually funny across the room.
I saw you looking over here too.
I was laughing.
So A and C would be x1 and
Wait. Okay, wait. A, B is,
it would be 2
plus
plus
2
2
to the power of 2
plus 4
4
minus 2
minus
minus 1.
Good.
Right.
So this is 4 to the power of 2 plus 8 to the power of 2. Then we get
Alright, so you have that.
16 to the power
So what I would do
plus
is
9, which equals
25?
so like 8-year-old.
So that's just 5.
which then equals
Draw the outline.
5.
And then that would be 5-year-old.
so far.
5.
Yeah, so.
Okay, you do the next one.
Okay.
So my point is that
The one itself is minus, but that's
I mean, I don't think you have to make that big.
Sure. I don't know. Add 10 and take away 1.
and now.
Add a 9 is adding 10.
wait, so it'd just be minus here though, right?
It's about like so.
So this was AB.
Yeah. Okay, so AB and CD are congruent.
What is the square root of 13, which is
Can you explain? Okay, you know.
3 times 2 and then 1.
I don't think you're.
I
What?
do it this way.
I don't think
Where-
you're
where's-
supposed to erase it.
We're gonna do it really simple.
Oh yeah, maybe.
That way you have two tools to find a line zero.
It's fine. It's fine.
Just
Okay.
you know what I'm saying. So I would say your best way is to draw out the graph,
And 2
and then plot points and find the
is what?
and how up and down, like,
Using the same.
Oh,
There's-
yeah, so you can make
using the same points.
For problem B, what I was saying is your best bet is to make your own graph and then graph it like that to then map out your triangle. And then find the legs and find the hypotenuse. Yes, A and B are the same answers, but it's two different ways of finding the answer, which is what I want you guys to do.
Wouldn't it be negative 2 plus 2?
Okay, so.
Segment A.
Oh. Wait, then wouldn't I have to subtract this then? Which also cannot be.
Oh, I pressed that.
You understood the question?
Wait.
I pressed
Is C supposed to be this angle?
Oh! Wait. Okay. Using the same points. Why? Why do you have to use the Pythagorean?
Yeah, no, I missed it.
You know what? I'm just gonna do it backwards. Because we're supposed to find X.
It's the same answer as A. It's 5.
With 4 points? But why do I need to use the Pythagorean
Oh.
theorem?
That's to prove that we learned.
Yeah, so use A and B to make have 2 points there.
I learned this in 7th grade.
Yeah, so you can have A and B is 1 segment and C and D.
I don't get why we need to use the Pythagorean theorem. And I don't know how.
You have this graph.
First, you have to find the.
These right here. These right here. That's your sequence. Now make a triangle like that.
I
don't think that you'll have two layers of changes. It's gonna. Oh,
What do we? I didn't read the question.
The summer grad.
Yeah, how did he get 5?
Wait. A equals 3x where's 3x?
Right there.
Watch your leg. Just trying to help you.
That's probably the answer to 3. I mean, not 3, C.
Find the length of the segment.
So what are we sending the answer to?
We still need to get B.
Oh!
I mean, that's still the
The
answer
one
to
that
C.
was so confused. I was like, that doesn't work.
So you can draw your own.
Okay. Oh, okay. How do you do it?
I don't know if because A, B, C, and D would be a square. So I don't know if we're just supposed to find A, B, and
What do we put in the Pythagorean theorem?
I would say your best bet is to draw it on a grid. You draw it in a graph. So.
-2.
And then plot your points. Oh my god, I thought you were using Sharpie for a second.
That's an option answer. Or B, right?
Those really are lines.
You thought I was gonna drop lines? Oh, sorry.
No. I meant points. It doesn't. The Pythagorean theorem doesn't. Okay, so this is A, right?
Yes.
B.
Wait, no. That's C.
That is C. Is that B?
B, yes.
Yeah. B. The distance between A and B. Oh.
This is on the board.
Yeah, we're. Huh. So we probably have to find.
So confusing.
We have to find this. B and C. The distance between B and C is not straight. Oh no, this is not right.
You have to use the distant formula anyway.
Yeah, I mean.
Mister! How do you do B?
So ready? I'm gonna redraw this. What's the point A and B?
Okay, A is -2, B is 2, 4. C is 3, 2.
Hold on, I'm just show you guys with just A and B. Alright? So that's my line string, alright, for A and B. Alright? How do I make a triangle? Alright? How long is this? How much should I go over? Ready? Look it. Ready?
4.
1, 2, 3, 4. And this is going off. 1, 2, 1, 2, 3. If your legs are a triangle, you find the hypotenuse now.
I don't know how we can easily get the answer.
I don't get why we have to do
All you need to do is find something that
The answer is 5.
the 10 or fairly close to 10 or fairly close to 10. Because then we just have to like look at the math that
Okay.
we're probably doing.
So plus 9?
D. No, there is no D. It just goes. It goes to E. I think. I don't know how to erase that.
I'm just gonna need to find something that
There's like 2 really easy answers you can think of.
Okay. Find the line.
First one was so easy. Just made her.
Fine, just allow a little bit larger and go over so that it's Congratulations, you guys finished early.
I think they're looking
The
for
square root of 105.
a point the same distance away. Okay, we have to break that.
Another set of, okay.
8 times 8 is what?
8 times 8 is 64. Wait, no. Yeah.
There's like one really easy one.
Wait, there isn't. That's just where we put the answer.
You just gotta find something that has under 10.
Oh. 10. So a line that's congruent Wait, no, it's not gonna be correct. Wait, yeah, it is. Zero. And 10.
So if I have you like
Just moving it
explain
a little bit, hold on, I'll move it back.
negative doesn't make a difference.
It was spinning.
Alright, guys, let's all head back to our seats. Let's all head back to our seats. Most of us are wrapping up.
Yeah.
How do you like that? I was doing carrying. My back hurt. My back hurt, you know.
Alright, so we're gonna go over this real quick. Alright.
That was 2 months ago.
Who's the oldest in the room?
I am.
I got it. Well, you look like me, nigga. You're only 16, bro. Yo, Tristan might be older than me. It's Tristan, mister. You older, right? How old are you?
Alright, so I got January 2006. Can anyone beat that?
No.
Alright, so you're gonna go, which board were you up at? Alright, I want you to, guys, let's listen up. Alright, I want you to explain to me how you did number one. Or A, I should say.
Ooh, bro, number
So I took the points that we got here, and then I just put it over there, and then I did 2 minus -2, and I got 4 squared. I did 4 minus 1, and I got 3 squared. And then when I like simplified the 4 squared, I got 16. When I simplified the 3 squared, I got 9. And then when I added them together, I got 25. What was that?
Yeah, square.
Square root of 25 is 5. So that's what I got. So I got 5 for AB, and then I did the same thing for CD, and I did -1 minus 3 squared, which got me to -4 squared, and then I did 5 minus 2 squared, which got me to 3 squared, and then -4 squared is 16, and then 3 squared is 9, 25, and then I split the square root of 9.
Perfect, that's exactly what you're supposed to do. So, what type of triangle is that? What are those numbers? It's a special one for Pythagorean. What? No. Isosceles, you had to make me cry. Oh my god, come on. Isosceles triangle. Isosceles triangle is when they have 2 of the same size.
I heard Group 10 talking about this, actually.
Oh, that's so cool.
It's a Pythagorean triplet, yes. 3, 4, 5.
I did that.
Well, yeah, that's what I was trying to leave you guys now. Alright, so.
You know, can I just add too, Demaya's group and then this group 10 I see, I don't think a lot of groups did it, but I want to point out, oh no, I saw group 5 did too. They wrote that congruency statement with the segment AB is congruent to CD.
Me and Evan are group 10.
Yeah.
Alright, since you're in group 10, you're gonna explain. Alright, explain
We're
DC.
group 9.
Explain DC.
Okay.
Explain DC. Come on, get up. You're gonna explain C.
Oh, whatever, got that.
Yep, you gotta go up. You gotta go explain C. You gotta stand up. You
No,
got
I
it.
didn't even
That's
do that
all
one.
you.
That was
Number
you.
three?
You know, I don't even know the back of zeros like that. I didn't do
Come on.
Oh, I'm doing 3?
Oh yeah. Come on. You wanted to stand up. You got camera. You're on camera now.
Wait, do 3?
Yeah, do E.
E.
Or not E. C.
Okay, I'll do that one.
Okay, guys, pay attention now. So, we did 3x minus 1 equals 8, and then we added the 1 to the each side, and then divided the 3x divided by 3, and then we did the 9 over 3, and then we got 3, and then x equals 3. That's the one.
Yeah. Alright, we're gonna go over E. And I told you I was gonna call on you and you're gonna go over
Actually,
E.
remember that?
Yeah, of course I did. I got a great memory. Alright, so you were on board 4, I believe. So since you didn't write out the work, you get to show us out how to do it now.
How do I?
I think that was great.
Mister, how do I?
You do it up there.
Oh yeah, do it up there.
Can I listen?
Go, E-Man. Yeah.
Alright guys, what's up? What's up?
Yeah, so like we're trying to find the length of these for the pairs right here. So I guess use the distance overlay. So like 9 minus 1.
Did they turn the camera
We got 7 minus 1. This is 8 squared. 6 squared. That's 64. That's 36. You add them together. I don't know, it's 100. You square root that. You get 10. And it says find an ordered pair that's the same length or something like that. So I just did a translation. So these, I just added 2 to each coordinates to like make it go up by 2 and stuff, you know. So yeah, so I did 3, and 11, 9. Yes. I'm not done yet. So like this, the original, the length was 10. So I just want to like make sure this equals that. So I just did the same process over again. So I did 11 minus 3 squared, 9 minus 3 squared. If you do it out, it's like that 8 squared plus 6 squared, and like it's gonna be the same process over again. So it's like 64 plus 36, which is 100, and it equals 10. So this equals that. So it's gonna go in.
I have a question. How did you know to do a translation?
Because it's like rigid motion.
She looks so happy.
See? So, just like we were going back towards the warm-up, you guys could have used any one of those rigid transformations to find out something that simple as like just given some random distance, and you have the points. You know that you could just translate it up. You guys could have reflected it over the x-axis or done something like that, and you could have got that answer really easy, really simple. You could have literally just moved it up 1 point. Or one of the ones I was thinking of was just doing 0, 0, and then just like 10, 0. Thought someone was just gonna do that. That way you're just like straight on the x-axis. I was waiting for someone to just do that. That one?
How much have you do?
Up 2. And then that's my thing.
Oh my goodness.
I was like, you got it. You like that much? You got a tattoo? Oh my god, that's so real.
geometry test in college, I had to wear long sleeves and cover up my tattoo because it was cheating. That's just a joke. My teacher assumed I knew it, but when I put it on my arm, I think she definitely knew I had it memorized. So she wasn't too worried about that one being the open. Alright, so good job, guys. We have one more problem set we're gonna go through, but I'm just gonna sit up here and talk to you guys for a little bit longer. So remember when I was going through the triangle and we had to go find that missing angle? So that's actually a theorem in math. It's called the third angle theorem. So what that means is when you have two given angles, that third angle is never going to change. Because it has to add up to 180, and just based on algebra alone, we can always find that last angle. Also, if we look at two other triangles, and we have two of their angles are the same, that means their third angle is also going to be the same. So I'll show you. Let's just say we have a triangle with all these angles. And let's just say that these ones are like that. Say like that. So, because in this triangle, we have just abstractly, like, I'm not just gonna write down any like angle measurements, just abstract thing. We have two known angles, right? And we have two known angles in this one. Since these two are the same, that means this last angle has to add up to 180, right?
Yeah.
Make sense? So no matter what. Yeah. Oh, 1, 2, 3. Yeah, because these have to add up to 180. So no matter what, that third angle is always going to be the same. So what we can get from this is when we start looking at other triangles like this, we can start getting congruent parts. So once we find out a triangle is congruent, we can do it one of three ways. So when we look at triangles, we could do it just based on angles alone. This is, if I wanted to prove that these two triangles are the same, I could do it by showing that all three of these angles are all the same. So I could say that these two triangles are congruent by something called angle, angle, and angle. Very simple. I have three angles and all the angles are all the same in them, so that way we know that these two triangles are the same, just based on angle, angle, angle. Then we can come over here. Take a wild guess. If that one was angle, 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 where am I going with this one? Side, side, side. Yeah, no, you're right. Side, side, side. What type of triangles are these ones? Isosceles, you got it. Bonus points. But, so this is another thing we could use. Side, side, side. Because if these two sides are the same, you know, what do you think? So what happens with this is if all these sides are the same triangle, it preserves all the angles in it too. So when we start looking at these triangles too, is we may be able to not know any of their angles on the inside, but what I do know now is that since this is a isosceles triangle, that this angle and this angle are going to be the same. So then in turn, and this triangle, this angle, and this angle are going to be the same. And then how about this angle? It's going to add to 180, alright. So what does this angle translate to in this triangle? It would be this top one, right? So based on just giving certain sides, we can then find out more about the triangle. All right, I'm going to give you guys one last one that's useful. I'll draw it right here. Hopefully you guys can see. All right, so this other one is going to be called side, angle, and then side. So by giving just those three things, and they have to be in that order. So it has to be one side of the triangle followed by an angle followed by another side. So it would look something like this. There's my side, there's my angle, and there's my other side. just what we could use is we could use some math properties, and we can find out that these two side lengths are then going to be the same. So I'll do 1, 2, 3, 1, 2, 3, and then we can then find out that these angles are also going to match up with each other. But it has to be done in that order. You can't do angle, side. It doesn't work like that.
So the angle with the two dashes and the one with three are equal?
Yeah. So these two triangles are congruent, just based on from knowing this side, this angle, and this side are congruent like this also.
So we'll get into the congruent, triangle proofs in January. The angle though, that's a similarity one, not a congruency one. Because if you don't have a side on that one, you can't have, it could be a dilated figure and still have the same angle.
Kind of like what I showed earlier in class when I drew the really big one.
There's actually 5 triangle proofs we'll explore in January.
I just wanted to kind of float these ones to you real quick, just so they're just somewhat in your head. Alright. You want to make new groups?
Yes.
Changing groups.
You like it.
Alright, guys. Hit it like a few more times. Just
How many? Sometimes I
Miss, I love this, Miss. You like that?
Alright, guys, quiet down. Guys, wait, quiet down, alright? You want to roll the dice.
Miss, let's keep it like that, Miss. I like that.
Roll the dice. Hey guys, quiet down. Just roll it anyway. Roll it. Roll it. Oh, please. Ready here. 4. Roll.
4.
Alright, find your new groups.
Let's go! I'm not doing shit. I ain't doing nothing, bro. I'm not doing anything. I'm not doing anything, bro.
I'm having you answer all the questions.
What?
I'm having you answer all the questions.
I can do that. Oh, yo.
Can you pass? Wait. Miss, you cannot change this. Who cares?
Alright, if you have a piece of paper, please bring it to your group. If you guys need another one, I'll pass on board.
Yo, man, I'm gonna do a new group.
Alright, guys, go to the whiteboard. Get ready to
Wait, are we supposed to keep this in papers?
Yeah. They was winning yesterday? I was so mad. I needed Travis Kelce to get a receiving touchdown, and I would have won $100.
That fumble must have killed you.
What?
That fumble must have killed you.
Yeah, tell me about it.
Find the missing.
Tell me about it. They don't need
Oh, yeah.
Okay.
Number 1. You're in group 1.
Yeah.
Find the missing side lengths of triangles to show they
We're on problem set 2. There's 4 of them.
So these are the triangles.
Wait, the mission lens?
Yeah.
Oh, yeah.
You wanna do it?
I'll do like, what? This one. There's like 2
Let's go, son. Let's go, son.
I like that I can do it.
15 squared is 225.
Oh, because I'm subtracting. Alright, anyways.
And then 225 plus 64.
See, as big as I am,
89.
Wait,
It should be square root. 29 squared is a big number.
And then I don't know the answer to that one.
I don't know if I can write it For the 289?
Yeah.
17.
17. Okay.
So yeah.
Oh, yeah, they're
I feel like
congruent.
we could have just.
Okay. Now B. Find the missing angles in the congruent triangles. Determine which triangles are congruent. And that's this triangle?
Yeah. No. Yeah, that's it.
Because usually, I mean, you're shooting. You're teaching already.
34 seconds.
105, so 175.
Mister, I have a question.
Yeah, of course.
Angle E and angle G are those congruent? I think it's
First, did you ask your group mates for help? They don't know what they're doing.
It's not.
It's just too wide. Oh yeah, so those are congruent. And so it's like 16.
Okay, so which are congruent?
Where's your guys' like math?
D and
This
F.
is it's a right triangle, so you can use
which triangles?
Find the missing angles in the following triangles. Determine which triangles are congruent.
So how would you set it up?
Based off of this.
This is my leg. This is
Yeah,
my leg.
those Is it like determined on like the angles and stuff? Because like sometimes angles aren't the same.
Oh yeah, you're right.
And then you can set none.
Mr. McGrath,
Yes.
can you assist us?
Save those for the second.
For number B, like none are congruent. Like
Not a congruent?
all the angle measures are different. Or is it just based off of looks?
What do you mean? It's not based on looks. So,
Because if it's based on looks, then these two would match. But they don't have the same angle.
so are they congruent or not congruent? If they're not congruent, that's perfectly fine. They don't have to be congruent. I want to just see if you guys could just do the A and see if they're congruent.
So they have like same angle measure. They have to have the same angle measure.
Yeah, so since these ones don't have the same angle measures, then none of them are. Yeah.
C.
We're on the last.
The two triangles are congruent in the image below. Find the missing values. Okay, I'll see. I'm just gonna draw it on the board. Oh my goodness, they really are trying to cut through.
Wait, is that E? Oh,
This is C.
I thought it was like E.
Let me draw you again. Oh, no. It's gonna.
And then, okay, this one is 10.
Oh, you
This one is.
Well, yeah, no, I can. Oh,
Okay, and this one is. So we already know that they are congruent. So with this one, we could do 64 plus 100.
You're gonna be responsible for your own actions right here.
And that gets you 164. And one third of that.
Square root of 4. I'm not sure that's how that works because that's not the hypotenuse. Because this is is this your angle?
Oh.
So it's c squared minus a squared.
Oh, I know what it is. This is 6. 345 is the triple, I think.
That's it.
Because scaled up by 2. 5 times 2 is 10, 4 times 2 is 8. So 3 times 2 is 6.
6. Yeah, that makes sense because 36 plus 64 plus 100.
Yeah. So if this is 6, okay.
8 squared is 62.
So this has to equal 10. So
Is that c plus 13 or something?
yeah, c plus 13 divided by, oh, it's actually 3 equals 10. So we have to get this to equal 30. So that should be 17. So
You gotta multiply the 3. So like 3 to get rid of like the denominator by like
Yeah.
so it's
oh, multiply it by
yeah, no, it's 3. So it's like c plus
Is it 17
13
and B and 15 equals
equals 10.
Just
to get rid of the denominator.
So it's c plus 13.
So it's like 3
but it's still 17 though.
Yeah.
Yeah, because you know we would get c plus 13 equals 30 minus the 13 you get 17.
Oh, alright.
So c equals 17. Okay, now this side is the 8. The 4a minus the 3 halves is 8.
So
with that one,
9.5 divided by 4. 9.5 divided by 4. Is it 9.5 divided by 4?
9.5?
Because 3.5. 3 halves is just 1.5.
Oh.
Oh no, wait.
You have one.
Yeah. So you add 1 half to
Oh yeah, that makes sense.
Okay. You need to be drawing this work actually.
So let me add.
Alright, we got that one to mind. Hold up. Wait, you got this. One thing covered.
It's 2.75.
So, the first triangle, should we write the triangle? Should we draw the triangle?
What is it equal?
2.375.
So.
Pretty sure.
Okay. And
I'll be right with you in a second. I just want to make sure this is still recording.
wait. Type in your calculator. 4 times 2.375 minus 1.5.
Oh. Well, I feel like it's just the same thing.
Yeah.
It equals 8.
Yeah, because I didn't
Okay.
you did this one already.
So
I did.
A
You already did
equals
67. No, that's one. Oh. Yeah, I didn't see that you had done it already.
and now the last one. 5b plus 3 equals 6. Minus 3 divided by 5. Do you want to put in the decimal?
I think that's perfect, yeah.
Okay. B equals. Okay. So that problem is completed.
Well, it'll be 120. Okay, then divided by 2.
Okay. Now number D. I mean letter D. Find the missing angles in ABC and determine if it's congruent to DEF. Okay. So the angle measures actually
Yeah, because since these two triangles are congruent, then we know that
99, 23, and 58. And then the triangle is formatted in this fashion. This kind of tilted.
Hey, where'd I go?
And
I had to erase you. Y'all could, I could have been on the side.
Well, we got.
okay.
I think you spelled my cookie's name wrong.
So
Where did she go?
A corresponds to D.
Oh, God, you ending, I got you.
It does. Okay. I'm just gonna write this triangle. So since A corresponds to D,
No, I know you.
It, hold on.
Questioning like why.
Isn't it like tilted? Yeah.
Yeah.
Ace corresponds to D. Yeah.
because it should have ABC.
Yeah.
Oh, yeah, they were, you were not in
Seven
the,
equals
each other.
I'll do like.
Can I draw you?
Yeah.
Oh, okay.
Oh, gosh.
Is it there?
With your hair?
For C, yeah, there's just.
Oh my gosh, what's up with her? That same type of
Was that 5x plus 24 equals 99?
Five x plus 4 should be equal to
Let's
58.
go around and look at
58? Okay.
Yeah. Okay, so
It's coming up on
okay, my A is congruent for me.
We're done. We're done.
Where's all your answers at, huh? You got all 4 answers all over here?
Four.
What you mean? 1, 2, 3, 4.
Oh, I thought
I can try.
Oh, man.
Alright, Sally, no more drawing right now.
One more draw, you got some more
This is
math.
Mr. Sard. I love math.
There we go. I'm actually trying, I was trying to find a good, t-shirt month.
You should definitely get out. I love math.
Oh, is it 24? Ah,
Yeah.
which is like, we're getting rid of 7.
Okay, let's do it.
Because, right, I got x equals 15, but when you plug 15 into the equation,
Oh,
it works.
that is the 34
And the only
and
prize is $20. I couldn't do it all that hard. Really? 8 a.m. is crazy.
Is yours congruent?
I got 28.6.
I'll plug it into the equation. Did you get 99?
Wait, no, I didn't.
Where's your work?
I got 58.
Okay, so they should be congruent. If two are already congruent, then they should be. Then it should be.
Why don't we do these two together?
9.5.
These two?
You see how that thing like
Okay.
Or these two together?
Oh, we finished.
Oh, they do.
That was fairly simple.
So then let's start with this one first. And then we go from this one.
Miss, we finished.
Focus on this one first.
So I
Where's our paper?
What is it?
You remember?
Very similar. Because it was a different.
Maya, how did you do this? I did exactly I don't know where to start. So he probably would. See, there's not a third one, so I wouldn't know. But it's probably like he did over there, like the lyrics, but there's not a third one, so I don't know. Like if you. I don't know if we're gonna start with that one in mind. But can you explain this one?
I want to see what
It's not even. Oh, it is recording. It doesn't have a wide view though.
So did they see me?
Yeah, they can see you where you're sitting from.
I can't see. But they didn't see me over there.
No, they can't because it has a wide view.
Where do they get A's from? No, I'm trying to see what they did and what we did, but I don't know where they got A's from.
I'm ahead, I'm playing through the midterm.
You guys have questions?
Yes, I have no
So we just are supposed to go. Alright.
give you your hug. And I get money.
And that's one stuff.
Do some work.
No, I get money. I don't know what you're talking about. I have a side hustle.
Alright, so ready?
I'm a hustler. Yes.
Oh, you dropped all my paper now?
Right.
Tell me about your,
your paper's not
But
But anyway, and I get money.
Alright, and it gets no money. Alright, so I would say start off with the triangle. So you have B equals 6. Alright, so now we can use these to find out all this. So I would say start off with this one first. And go set C plus equal to Alright guys, it's all into our seats. It's all into our seats.
Anyway, we'll be standing here. But we're not gonna make it.
I'm gonna explain it.
That's the Mayan.
But I wasn't done.
It was amazing when they packed into that small space
Alright guys, so were these ones a little more challenging than the last ones? Yeah, I feel like some of you guys finished really quick and some of you guys are like taking it the whole time. But it's alright, we're gonna go over it real quick. Alright. So you did all this. Marcus is listening to music. Mr. Lazard, do you have any good prompts you want to make someone to explain one of the problems? Tall, short.
Wait, what? Tall, short.
Hold up. I'm one inch taller. All of a sudden.
Alright, so
When you guys latest last night?
I would
We're watching at 9 o'clock.
Who wants to make the latest?
Damn!
Who went to bed the latest? What time did you go to bed?
I went to bed early.
I went to bed at 8 o'clock.
I went to 2:30.
I still got you guys all.
I'm sorry, I like the new Fortnite chat. Got my win last night.
Yeah, you missed. No, wait.
You want to do it?
Alright, so I would have you explain part A on problem set 2. So where's your board?
Up here, number 1.
Yes.
Alright, so walk us through the first section.
We didn't label this. I have no clue what it is.
What?
What one was it?
Who did this? Who did this?
That's it.
Had to be him. He tried to sabotage my whole entire reputation over it.
In trouble. So basically, we knew our BA side was the same. So on FDE, we did the Pythagorean theorem to figure out what our C length was. We saw that in math. In math, ABC, that means we have 2 equal sides on ABC. So.
So what were your answers?
It just says C was 17 and B was 15? Yeah.
Yeah. Alright, perfect. Good job.
Good job.
I'll ask all of you this. In part B, were any of the triangles congruent? No. Guess what? Sometimes there's no right answer, and that's okay. Why do you guys get confused when like you guys get like a bunch of B's in a row on like a multiple choice, or if you guys like have like there's just no right answer? I had a chemistry teacher one time made all the answers on her test B. Easy grade, but boy did it psych us all out. But I just want to just go show you sometimes there's no right answer, sometimes all the right answers, maybe like one choice. It's okay. So don't be like stressed out or too worried that you're doing something wrong. Alright. Moving on to problem C. Does anyone want to explain it? Anyone want to be the teacher? Oh, let's go. Actually a volunteer.
So basically, first on the triangle FED,
Oh man. Sure, why don't you know?
So with triangle DEF, I first found side length B, and I got 6 because it was a triple. And then after I got all the side lengths, I set them equal to their corresponding sides on ABC. So side 6, 6 I set it equal to 5B plus 3, and then I got 3/5 for A. For side A, I got 2.375, and side C I got 17.
So, did you guys notice something in triangle FDE? The triple. So, the side lengths for that one measured as follows. It was 8, 6, and 10. What do all those have in common? What? They're all even, but they're all even because of this. 4, 3, and 5. When I made this, I just took that triangle 4, 3, 5, or the 3, 5, 4 one, and just multiplied it by 2. And boom, there we go. Now you get a whole new triangle with all new dimensions that is still the exact same. So you could do that with these triples and these triplets to make it a little bit easier. If you can start seeing common themes like that, as long as you multiply it all by like a scale factor like that, it'll still be the same. This thing is just a dilation from just that 3, 4, 5 one.
You guys, if you know those triples, it is gonna save you so much time in your math life.
Yeah. Just by knowing that, like 3, 4, 5 one, even on I think I did it on one of these. It was 8, 17 or 8. I was on the other one, like 8, 13, 17. What I want to say, or something like that. 15. That was also a triple. So I'm hiding something from you? Why am I hiding something?
Right, that's so not bad.
Alright, so another thing I also want to touch on is from that last one is Xavier put it perfectly, is that they correspond the right way. So let's all go through this real quick. Alright, so we have AC. What is AC congruent to? It's congruent to 6, but what side length and FED? Wait, what? DE? Alright, what about BA? And BC? FD? Alright, so if I wanted to write that triangle ABC is congruent, what order would I write the other ones in? DEF. So when we write it, you want it to follow the same path. So if we have a triangle like this, we said, who has one up there? But we want to follow it along the same image. So if we're going to go A, B, C, well, my AB has to correspond with, what do we say? AB right here, FE. So that way it's going to go FE. So we want to follow along the same path as we go along the triangle. So if I go ABC, we're going to go ABC. We're going to go FED. Because AB corresponds with the FE, the BC corresponds with that. So that way we know which parts it corresponds to also. Well, yes, if you could like mix up the order, it still is the same triangle, but this is a more logical sense and just what is more practice in math. Alright, so who went to bed the earliest? Went to bed the earliest? Oh, who woke up and actually ate breakfast this morning? Oh, one person.
No, I see
Oh,
you.
two?
Over there, we got.
That's what I said. Not a lot of people. Alright, Jordan, can you explain? Did anyone get to D? Anyone get to D? You got to D? Oh, you're explaining for me then.
I mean, we didn't have it on the board.
You don't have it anymore?
Shut the hell up, bro. Shut up.
You guys got D?
Alright,
Guys, listen up. She's gonna go through D for those of you guys that did not get to it.
Okay. So for D, I don't know. Can y'all see this? Yeah.
You should rewrite it. You write my stuff if you need to.
Okay. So for D, since they're both congruent, so wait. To determine if they're congruent, since we know that inside equals 180, what my team did together, we wrote down all the equations for the angles, and they set them equal to 180. So. Then we remove all the numbers. We distribute it out. I did not know how to say that. But we just figure it out for the equations and it just takes a while. You know what? Let's just do it all at once.
There you go.
Then we get, if we take that all out, we get
Why can't it be up versus house? I know, right? Yeah. I want to see. I don't know.
Alright, so you guys all see how she did that? You guys all pay attention.
Yeah.
So, took the triangle, added up 20. So, and then she got x equals 15, and then to find out if it's congruent, she went back into that triangle with all the missing angle measurements, and you plug in the 15 for all the x values. Yes. So now that you have x equals 15. So we have x equals 15, so we can go into all these triangles right here. We can find these last three missing measurements. So let's do it real quick. So someone 3 times 15 plus 13. Someone want to do that for me in the calculator real quick? 58, that's right. There you go. 58. Alright, so we have 2 times 15 minus 7. Someone want to do that for me real quick? 3. And 5 times 15 plus 24. 99. Alright. Add up 58 plus 23 plus 99. 180. Look at that. Ain't that cool? Alright guys. So do you guys have any last bits of questions? Anything that you have any burning desire to know about triangles and congruency?
No. No. Thank you, sir. Thank you.
Yeah, because it's the question.
Next we got HMH. Nothing right? Like this.
I would see if someone.
Now, I gotta figure out who.
No, I added those now, but I took it back. Wednesday we'll see you guys.
When's the text?
There was a little birdie.
When's the text?
About somebody that happened on the dance. Oh, what you're doing now? Yeah. Oh, yeah. I'm sorry. It was on. That'd be the problem. Huh?
Quiz, and then that week before.
It's always that.
Alright guys, everyone say hi to my professor, Professor Melgambe.
What?
Yo, what's good, my homie? What up?
Hey, did you practice?
Alright, hey listen guys, can I have your attention super quick? Thank you very much. I'll let me grab it. So if you just to let you know, just to reset.